Like, I'll just throw a little something in there and see what everybody thinks. We could certainly talk about chromosome 2 fusion if you'd like, wherever this conversation would go. But the first thing that I had in mind was, as it pertains to the peer-reviewed literature, the data, I would argue, is of utmost importance. The conclusions are good, but oftentimes the conclusions of a lot of these papers comprise a lot of untested hypotheses and a lot of possible inferences. They'll oftentimes concede right in their conclusions or discussion portion of these papers. They'll admit what they're putting forth in terms of an explanation of this data is tentative. And so basically I'll say this, and then we'll get some thoughts from everybody. I think we could essentially refute common ancestry from the secular literature just by looking at the data. So here's one data point that I find to be fascinating, and it has to do with your Y chromosomes of the great apes. So your humans, chimpanzees, bonobos, gorillas, orangutans. And so the Y chromosome, as we know, is uniparentally inherited DNA. It doesn't experience recombination. And so you're not going to get the shuffling of DNA variety every single generation. And so, it should more or less be stable. And so every single human Y chromosome on the planet, when we sequence the Y chromosome worldwide, is nearly identical, 99.9% basically the same. But when we sequence, and right here, this is newer data, which I find interesting. Some of this data we didn't previously have, at least before 2017. We've got preliminary data in terms of the sequence of the Y chromosome in all your different great apes. And so you'll notice when we compared the human to the chimpanzee, which is supposedly our closest common ancestor, firstly, it's half the size. Oops. You can see it right here. The chimpanzee Y chromosome is only half the size as the human Y chromosome. Apparently, we split from a common ancestor with the chimpanzee between 6 and 10 million years ago. And the human Y and the gorilla Y, you can notice here, if you compare them, they're actually more similar to each other than either are to the chimpanzee Y. And so there's an inconsistency in the nested hierarchy. And so basically my argument comes down to a case for separate ancestry. We would argue that humans are independently created, separate from your other great apes. Evolutionists or taxonomists would say humans are human great apes, chimpanzees.
What's the basal condition, Donny, on 6?
So you're saying the human and the chimpanzee, the common ancestor?
No, yeah, on 6, what's the basal condition look like? I'm curious. Do you have the basal condition there?
Probably in the paper itself. I think 6 here is hypothetical, so they don't have the basal. I highly doubt that they have the basal condition for 6.
They probably don't have the basal condition for 7 either.
Funniest thing is I don't even need to talk anymore because standing for truth's here. Before, the guys avoided my question, and one question they avoided. They say that at CERN they sprint particles around this long tube and they smash them into each other, and then gold appears where there was no gold before. Well, that was the energy that was already there that created the gold, right, Stanley? And this is where they're coming from. They try to avoid that question every time. That's all I was trying to say, Stanley. It's not an important question, and you're killing them, so I'm going to shut up now.
Well, I appreciate that, Jason. And basically, I'll wrap it up with this. And to answer your question, Bree, I'm pretty sure these nodes here would be inferred. We don't have the data for your human, chimpanzee, and bonobo common ancestor here at 6 or back to 7 or 13. But what we do have is this data. Mm-hmm. And essentially, when we consider overall architecture, gene content, and size differences, the human and chimpanzee Y chromosomes are only about 35% the same. And so the evolutionists would have to account for those massive differences in about 6 to 10 million years since the split. And so my position would be that the most parsimonious explanation would be separate ancestry, that the reason why the Y chromosomes are so drastically different between humans and chimpanzees is because humans and chimpanzees aren't related in the first place. And so I said
Well,
a lot.
it wouldn't say they weren't related in the first place, right? It would just push the relation closer to gorillas then at that point, right? That's the inference you would make from the data correction that you're seeing here with the Y chromosome. And that's based on not knowing what the ancestral condition of node 6 and 7 is, yet alone the node of 13. Am I right?
Mm-hmm.
We don't even know with the Borneo orangutans, for instance.
Yeah, and I do note that the paper does say that substantial differences in Y chromosome structures don't apparently seem to indicate whether something can breed or not. And I will quote from this paper: despite the substantial differences in their Y chromosome structure, both the chimpanzee and bonobo and the Bornean and Sumatran orangutans are able to produce viable fertile hybrids in captivity. This suggests that structural changes in MSY is probably not accompanied by physically significant change in gene content. So that statement from them just blows all of that out of the water, Donny. You can point to differences in Y chromosome all that you want. It doesn't seem to impact whether that is actually a significant difference or not, as far as gene content is concerned. And you did mention that only 35% of chromosomes are similar. I'd like to see where you got that study from and how they're measuring the comparison between gene sequences in those chromosomes.
Well, fair points. Good question. Firstly, you can look at the diagram itself and quickly note that the chimpanzee and human Y chromosomes are half the size. The chimpanzee is half the size of the human Y. And so right off the bat, you're starting with 50% difference. And so over here, they admit this in the paper. Despite a recent divergence of these species, their Y chromosomes differ enormously in size and gene content. The chimpanzee Y, so they admit this in this specific paper, the chimpanzee Y is only half the size of the human Y.
Donny,
so right off the bat, you're starting with 50%.
Can you clarify some of the terminology here? So it says, despite recent divergence of the species.
Doug's got heaps of friends that are male nurses.
What does divergence mean?
Well, Bree, do you know what divergence means, or are you just trying to give me an evolutionist
I'm being facetious with you. Absolutely.
Yeah, no, I understand. I think we all understand what divergence means. So more than 7. Okay, well,
Donny, your own paper goes on to say that dissimilarity between the Y chromosomes does not equal dissimilarity of gene content. You know that it says that, right?
The gene content within the alignable regions, you're saying?
Yes. But it also suggests that just because the Y chromosomes are different, it doesn't mean that they didn't have a common ancestor.
It depends how different. So once you get into
the chromosomes between chimpanzee and bonobo are very dissimilar as well, but their gene content, the content of their entire genome, allows them to interbreed still.
Right. My argument is not related to whether or not they can interbreed. My argument pertains to a waiting time problem, as in the evolutionist now has to provide, because if you actually read these papers, they suggest a number of mostly untested hypotheses pertaining to faster rates of gene conversion. They talk about sperm competition, polygamous relationships within chimpanzee and bonobo groups might mean that the Y chromosome changes a lot faster. But at this point in time, they will admit or concede that a lot of these are untested or unverified hypotheses in terms of whether or not these factors can account for such massive differences. And that's why they point out, right? I'll just say this and then take your time.
Okay.
Thanks for saving my ass, Danny.
And that's why they point out here in the paper itself that the percentage of gene families shared by these two chromosomes, and just to answer every question, so the recent divergence of these species more than 7 million years ago basically is talking about how your humans and chimpanzees shared a common ancestor. Let's say, numbers differ, let's say between 6 and 10 million years is typically a safe number to go with. Well, at that point, you'd have a split or a divergence where you have, the human line going one way, chimpanzee going another way. And so if humans are genetically homogeneous within themselves in terms of the Y chromosome, which we know is the case, humans are about 99.9% similar in the Y. But when we compare humans and chimpanzees, our supposed closest cousin, it's about 35 to 40% the same when you consider the size differences as well. And so the evolutionary community is going to have to argue for independent changes since that divergence, basically. And so you'll notice here the percentage of gene families shared by these two chromosomes, they give the numbers, and they admit here is similar to that shared by human and chicken autosomes, and so biparentally inherited DNA rather than the uniparentally. That's split 310 million years ago. So, and they admit here, puzzlingly, so it wasn't necessarily expected or predicted. They admit in terms of shared genes and overall architecture, the human Y is more similar to the gorilla Y than to the chimpanzee Y. And you can see that in the diagram itself, where you've got the gorilla Y here. You can compare the gorilla with the human Y. Here's your chimpanzee Y. So human and gorilla are more similar to each other than the gorilla is to the chimpanzee or the human is to the chimpanzee. Last thing I'll say is my argument comes down to the evolutionists requiring a mathematical model, not just untested hypotheses, but an actual model that explains how these massive differences can come about within the 6 to 10 million years in a chromosome that should be relatively more stable since it doesn't experience recombination. Go ahead.
No, that's absolutely incorrect. And your own paper refutes that. It actually says over many millions of years, the X chromosome has retained most of its ancestral content and is highly conserved across a wide range of mammalian species. By contrast, the Y chromosome has lost most of its original content and is characterized by very rapid evolution across species. This is what your paper says. Suppression of recombination and a constitutive haploid state have led to a degeneration of the male-specific region of the chromosome, as well as an intrachromosomal rearrangements, evolution of ampliconic repeat regions, and the accumulation of male gametogenesis genes. Throughout the process, however, a pseudo-autosomal region has been retained, shared with the X. This permits crossover between the sex chromosomes and ensures proper meiotic segregation into the gametes. So what it's basically saying is that the Y chromosome is not stable, and you are completely misrepresenting that for saying that, because I can show you a paragraph just in the introduction which says that the Y chromosome is not stable, when compared with the X chromosome. Now, the pressures that make these more or less stable and why the chimpanzee may have diverged more could be evolutionary pressures. There is nothing that you have said that sort of refutes that. And looking at a picture of something and saying, well, that looks like this, is not a very reliable way to sort of understand the processes that are going on in here. I mean, basically, you're just saying, look at this picture. It's essentially what Kent Hovind does. He says, look at the picture of this, connection between primitive life forms and today. It's an argument from incredulity, Donny, and I think you know that.
Okay, fair points. Let me address each in turn. So I think you just proved my point, Mark, that the hypotheses put forward in terms of massive loss of certain portions of your Y chromosome, sperm competition, the number of possible factors, contributing factors that are provided in these papers. And you can look at the original, I believe it's in either 2006, right here, it'll tell us, 2010, where it talks about the incredible dissimilarity between the human and chimpanzee Y chromosomes. This is a more recent paper where we actually have numbers for the most part associated with gorillas and bonobos, which is helpful. And so those are possible factors in explaining the massive differences. But again, they have not put forth a sophisticated mathematical model. It's basically just a just so story at this point. Maybe this, maybe that. But what the data actually suggests is that within all humans, the Y chromosome variation is extremely homogeneous. We're all about 99.99% the same. And it turns out that the Y chromosome mutates fast. And so the Y chromosome experiences a lot of mutations per generation, about 3 per generation. But yet every single human male Y chromosome is nearly identical. And so if we go back, let's say 200,000 years to an out of Africa event where coalescence essentially allowed one Y chromosome lineage to make it through to today, we'd expect some highly divergent Y chromosome people groups. And as far as I know, we don't find that on the globe. But the most important point is, if we supposedly split from a common ancestor with the chimpanzee, why are we so similar, even in light of a faster mutation rate? And yet humans and chimpanzees are only 35% the same. And we can go through each number here. You know, a visual is always helpful because it doesn't take a genius to see that your gorilla Y and your human Y, just as they admit in the paper, are far more similar to each other than the human is to the chimpanzee and the gorilla is
similar
to the
about them. I mean, I know they have.
I'm almost okay, just because Mark made a lot of points. I want to address them all.
Okay.
So we can actually go into the various papers themselves. For example, this one in 2020. This photo itself from 2017. So even in 2020, if you read through the paper, they're pointing out that, yeah, there's this number of factors that might contribute to these massive differences. But I want to see a sophisticated mathematical model and not just, well, this could explain it or that could explain it. I mean, that's just a story, and you have a right to that story. But I like to say, cool story, bro. And so right here in 2010, you can actually go through the paper itself and read about all the differences, right? It gets technical, but it's there. The chimpanzee MSY harbors twice as many massive palindromes as the human MSY, and you can go through it. But for a lay audience, visuals are always very helpful. And I don't think anybody is going to miss the fact that your chimpanzee Y, notice this, is incredibly different to the human Y. Point is, we have 2 competing models. Separate ancestry model, universal common ancestry model. This is exactly what the separate ancestry model would predict. But these papers are admitting that this data is puzzling. And yes, maybe this, maybe that could explain the differences. But at this point, it is an unsupported group of hypotheses. Go ahead. I appreciate the time.
Well, what's an unsupported hypothesis is the separate ancestry hypothesis that you're trying to link with this picture that says nothing of the sort. In fact, your own paper refutes you, Donny. It refutes you. Even though the human MSY was fully sequenced in 2003, Y chromosome sequences for other species have been slow to follow. This has been for 2 main reasons. First, large DNA scale sequencing projects have traditionally used female samples. And secondly, the complexity of Y chromosome sequence, rich in segmental duplications and repeats, make it almost impossible to assemble accurately using short read sequencing technologies. So it is entirely expected by the evolution that the Y chromosome will be completely different in completely different species. And your own paper says, even though they are different in different species, they are not so genetically dissimilar to not be able to breed. The bonobo and the chimpanzee can breed. The 2 types of orangutans can interbreed. Just because they are dissimilar doesn't mean there was no common ancestry. And your paper says that explicitly. So you're kind of misrepresenting this graphic to say, hey, look how dissimilar they are, which is exactly what we would expect from an evolution standpoint.
Yeah, I'm
That's
looking
exactly
at this and I'm seeing the orangutans being, one of the orangutans being closer to the gorilla and the other one being closer to human too, or closer to the chimpanzee.
But those orangutans can interbreed because they had a common ancestor. And the whole idea that, well, humans are so different, it's got nothing to do with having a common ancestor because the Y chromosome is so volatile, and your own paper says that. Now, the whole idea that sort of chimps are so different, well, why is the X chromosome so similar? They're almost identical between the human and chimpanzee. So if they had separate ancestor, we would not see an identical X chromosome. They would be completely different as well. But that isn't what we see. We see that they are identical. And I thought this was going to be about chromosome 2 fusion, but never mind.
can I ask something real quick about this graphic? Is there a key to it? Because it's weird to see a graphic like this without a key included.
Well, you can click the paper itself and read it all. So I want to respond to a few points. So again, Mark, guys, if it's a 2-on-1, I got.
I'm leaving actually, Donny. I'm leaving.
I've got the publication. Well, I just want to say, here's the publication. Here's where the picture comes from. Here's the source for this one. Here's the source for this. Everything I'm saying, the sources are up here. Save it, screenshot it, and go check it out on your own. So what you're asking for, I'm sure, is there within the paper itself. But Bree, if you said you were leaving, feel free to have some final words before I respond to Mark.
Oh yeah, no, that's all I was going to say is I'll look at I'll look at the key to this and kind of understand, because there's like sections, like when I look at this, there's sections of gray in areas and black in areas, and I don't know what that's supposed to represent.
Oh yes, yeah, I get it. Yeah. The key to it, like the different areas, like
I need to know what I'm looking at to understand
it's all
what
there.
The differences represent. Otherwise,
actually, specifically, what I'd recommend, Bree, is go to this paper. This is the one I've read in detail numerous times, from 2010. Chimpanzee and human Y chromosomes are remarkably divergent in structure and gene content. You've got the key there. And it goes through all your different, basically colored portions. And it says, here's the difference between the X-transposed regions, the ampliconic regions, and it'll give you all that. The size differences, it'll all be there for you.
All right. And I think Mark was really looking forward to the chromosome 2 fusion topic. I will be in the side chat. So you guys have a good night, okay?
That's okay. You don't have to leave, Bree. You're okay to.
I have to go to bed. I got to work in the morning.
Oh, okay. Sorry. Well,
come on, Bree. Get a coffee going and pull an all-nighter with us. It's worth it. Is Bree gone? I guess my peer pressure didn't work too well there. All the cool kids are doing it. Okay, so a couple things I'll respond to, and we could always talk about chromosome 2 fusion. It wasn't. All of this is unplanned, so I'm happy to talk.
They just go quiet when you're up there, mate. You just destroy them. They don't even have an answer, really. They try, but they just, I feel sorry for them, really, when you're up there, man. I don't want to give you a swelled head or anything, but you're doing pretty well.
Well, I've been called a lot of things, but quiet hasn't been one of them. That's a new one for me.
Mark and quiet, 2 words that don't go together.
Yeah, do not go together.
So where are all the saints and faithful brethren in this group tonight? Can they identify themselves?
Well, listen, let me just respond before I forget, okay?
We're talking about a technical topic. When was the letter J invented?
Move on.
Standing for truth, there was a guy on Praise the other night, and he was going on about Enoch, how Enoch is like scriptural, right? And I posted all that stuff about, that doc I've got about Enoch being unscriptural. And he was saying he was going to debate you and he's going to destroy you and he was going to prove Enoch is scriptural and that all this sort of stuff, mate. Like, honestly, you need to find out from Praise. I've got guys there tonight. We've got his name. You need to find this guy because he was so big on debating you, and then all of a sudden we can't find him anymore. And he was going to debate you on.
Who is this? Okay, well, okay, I appreciate it. I just want to respond to these points. So I would argue, and Mark obviously will disagree with this, and that's completely fine. The number of factors provided in terms of the massive gene loss, the massive reorganization of the Y chromosomes over the last 6 to 10 million years, faster rates of gene conversion, sperm competition, polygamous relationships within bonobo and chimpanzee groups. I've read all these papers and I've heard it over and over again. If I had $1 for each time that I've heard these rescue devices being purported as a solution, I'd be a very rich man. Okay, so I'm just asking for a mathematical, the evolutionists like to say you have a heat problem and we give, 10 to 20 possible solutions. And then you get your evolutionists that say, okay, show me a mathematical model. I want to see it on paper. And
Sam, just before you finish, I just want to ask when the word letter J was invented. That's all. When you finish, later. Bye.
Okay, thanks, Jason. And so fair point. Right, we can have 10 to 20 possible explanations where some of them seem pretty plausible. But for it to be empirical, we need to have some data. We need to have a model presented, not just a just so story. And so what I've seen so far and not just with Mark, I've debated PhD evolutionists on this same topic, basically to every single possible reason for the massive discrepancy in the Y chromosome, I say, cool story, bro. But what I want to point out in terms of the predictions of the separate ancestry model. So here is a visual in terms of the model I would hold to. And so we'd say you got humans, all your living humans, extant humans, go back to Adam and Eve. You've got your side branches, Erectus, Neanderthalensis, Naledi, so on and so forth. Then you've got your Australopith-like ancestors, orangutan, its own kind, your chimpanzee, your gorilla. Well, it turns out that the Y chromosome data actually perfectly corroborates that, or it's perfectly consistent, I should say.
Sorry, could you go back to that for 1 second? That
Yes.
other graphic of your model?
There you go.
Where are bonobos?
We would have bonobos within the chimpanzee
Okay.
lineage. So we'd have chimpanzees and bonobos essentially going back to a common archetype, and then back to ancestors at creation. That's a good observation, Mark. I appreciate it. And so when we look at the Y chromosome data, the uniparentally inherited DNA data, we've got your humans that we would argue are their own created kind based on this data. Chimpanzees and bonobos are the closest to each other, and so we'd argue they go back to an archetype. Your gorillas and the humans being more alike than your humans and the chimpanzees, we'd say the gorillas are their own kind. And then your orangutans, and you can see that your orangutan varieties here are very close. And so it's not necessarily about the ability to interbreed. And so chimpanzees and bonobos being able to, let's say, for sake of argument, they can produce fertile offspring. And so can the orangutan varieties. Yeah, that's what we'd expect, because we believe those are part of the same created kind. I'd be surprised if a gorilla and orangutan could, produce fertile offspring, or a gorilla and a bonobo, let's say. But as of now, in terms of what we would predict in the separate ancestry model, the Y chromosome data fits perfectly. And last thing I'll say is I completely understand what you're saying, Mark, in terms of the massive gene loss and a lot of these hypotheticals in terms of what has occurred in the last 6 to 10 million years. Unfortunately, we don't have the data to tell us exactly if these massive losses and reorganization within the Y chromosomes occurred. But I do look forward to a mathematical model being presented, hopefully in the future, when evolutionists or evolutionary scientists, look into this a little more. So go ahead.
Yeah. Okay. So I think you've sort of pushed back against your own idea that the X chromosome shouldn't change if they are from the same separate lineage that you're talking, in the orchid pattern that you're talking, because the chimpanzee and bonobo are quite different and well. In fact, there's a segment of the bonobo there that the chimpanzee just doesn't have. And if you actually look at if you look at this graph, even the human, the top of its Y chromosome is more similar to the chimpanzee than it is to the gorilla. So we're not just looking at, which one's longer, which one's shorter. We're looking at the similarities between them. And the idea that the Y chromosome has to be similar if they come from the same ancestor that you've put forward. Well, the chimpanzee and bonobo, why don't they have the same Y chromosome then? Why is theirs so dissimilar? Why are the orangutans so dissimilar? The problem also is, and you didn't answer, is why the X chromosomes are almost identical. In fact, they're almost identical, except for maybe, I think the gorilla has one separate band at the bottom that the others do not have. It's incredibly similar. And none of this is a just so story, by the way. There is other evidence to back this up. And this is exactly what we'd expect if your paper is correct, and it says that the Y chromosome does vary so much that we can hardly keep track of it, and it's very difficult to gather data about it. So I think you've sort of avoided all of the questions that I've answered, and just reiterate that because they look similar to you or they look different to you, then there can't be common ancestor, which again is just an argument from incredulity.
Okay, I'll quickly respond, and then I'll give Mark the final word, and we can move on to a different topic if you'd like. So I'd be quick. X chromosome similarity. I mean, I don't really see why there's anything to describe to explain. There's going to be certain parts of the genetics of all living organisms. By definition, every single organism has to be more similar to each other than another organism, because we're made with DNA, RNA, proteins, similar in morphology and phenotype, which is basically a reflection of the underlying genotype. And so the X chromosomes are similar for exactly what a creationist would say, common design. But the Y chromosome, the issue is it's not just similar, right? Because there is a roughly 35% similarity. The problem is the waiting time issue here to explain such massive differences within that hypothetical 6 to 10 million years, basically, since the split. But also why, even in light of a fast mutation rate in human Y chromosomes, about 3 per generation, that's fast. There's only between 300 and 400 DNA differences separating us from, your Adam consensus sequence, really, in terms of Y chromosomal variation. So it doesn't take very long to accumulate that amount of variation. You'd expect, again, I pointed out earlier, that if you go back 200,000 years to an out of Africa dispersal event, why don't we find highly divergent Y chromosome people groups on the planet? I mean, you have people that migrate to different parts of the globe. They're separated, accumulating independent mutations in the Y chromosome. If the Y chromosome is rapidly changing, seems to be the case, why is every single male Y chromosome still so uniform and homogeneous? But fair point to the bonobo. So the bonobo and chimpanzee Y chromosomes are still more similar to each other than when you compare the human, gorilla, and orangutan Y chromosomes. And so a couple of these factors may be worth considering. And that includes
truth. Wasn't it just an article just released by Science or something? Was that showed that humans are no more different from chimps to chickens and mice and stuff like that? Wasn't there just a new thing released or something?
That's a good question. What they're referring to here is from the paper itself, but we want to be clear. So the Y chromosome is uniparentally inherited DNA. So there's no recombination. It's not autosomal nuclear DNA, but it is nuclear DNA, but it's not autosomal. Okay. So there's no scrambling per generation, although there is some evidence that you get a little bit of gene conversion, swapping of single nucleotides. But in the paper, they say, well, this is what we would have expected. Notice this. The chimpanzee Y is only half the size of the human Y, and they say that the amount of differences that were discovered is what they would have expected between humans and chickens. But they're comparing that to autosomes. So it's not necessarily comparing apples to apples here, but they are pointing out in the paper, like, this is an amount in terms of differences that wasn't necessarily predicted. But here's the last thing I want to say is the creationist as well, when it comes to ancestry. We may have to explain what is pretty minor differences within the bonobo and chimpanzee Y chromosomes when you compare their Y chromosomes to the humans. I mean, it's just so drastic. And so here's the challenge that I have, and I'd love to really get a mathematical model, not just a repeating of what the papers already propose. They admit in the papers and the associated articles that these are hypotheses, but we still need more data. We need more testing. We need a mathematical model to what? Notice here, they are now going to have to apply mathematical models to try to demonstrate how a sequence can change extremely rapidly, including wholesale rearrangement of significant parts and the evolution of entire gene families in a relatively short amount of time, yet stay homogeneous within a species. What that part means is what I've been saying. Human Y chromosome, 99.9% the same, yet the Y chromosome mutates fast. And the human and chimpanzee Y is only about 35% the same if we consider size differences. So I understand everything Mark is saying. He's basically just repeating what the papers say in terms of some possible factors. But what we have not yet been given by any evolutionary scientist is a mathematical model to actually verify or strengthen these possible explanations. Go ahead. I'll give Mark the final word on this specific topic.
Yeah, so I noticed that isn't actually a peer-reviewed scientific paper that you're looking at right now. It's from creation.com, so it hasn't actually passed peer review and is not scientists saying that at all, as much as you sort of suggest that and let people think that. That is actually from people that are not working in the field commenting on it. So that entire thing is sort of them saying, hey, we need a mathematical model. They're not even scientists working on it. That is irrelevant. That's just if I brought up a website from, Iron Chariots or something. It wouldn't hold any scientific weight. So, Donny, that's not a proper scientific paper. So, that's just somebody claiming they need a mathematical model and they don't have one, when in fact they do have some hypothesis how that happened. But that's not what evolution is built on.
Well, can you send me their mathematical model? I just want to know, can you send me the mathematical model in detail?
You can't. So that's like asking for a mathematical model of what the weather's going to be like. Evolution has so many different pressures.
Mark, you can't just say, well, maybe this, maybe that, and then move on.
Can I speak, please? It's got so many different pressures.
I'm just glad you admitted you don't have a mathematical model.
It's got so many different variables that you cannot just put in a formula and get what things are going to be like. I'll just quote from your own paper again. So meaningful size comparisons are difficult because of the presence in some species of large blocks of polymorphic heterochromatin. For instance, the length of human MSI is given as roughly 57 megabits in the UCSC genome browser, but about 30 megabits of this is the YQ heterochromin. And in reality, reality among humans varies considerably in length, from 29 to 54% of the metaphase chromosome length in one study of 47 Y chromosomes, and that's Repping et al. 2006. So what it's basically saying that even in humans, it's not a standard length, as much as Donny wants to pretend it is, because sort of heterochromium, polymorphic heterochromium, which can differ in size, that's polymorphic, it differs in size, you can get different size differences among them. And that's because this Y chromosome is so volatile, and Donny's own paper says that. Now he wants to come in with a creation.com thing to say, hey, there's no mathematical model, but what you're looking at is things that are so specific to evolutionary pressures. There's so much chaos involved, so many things can happen. I don't know how you're supposed to give a mathematical model for that. All the development of those Y chromosomes depends on so many factors, and he's trying to say that's a disadvantage for the evolutionary side. Well, it isn't, and this is exactly what we expect to see when we see the Y chromosome, because of how much it does fluctuate over time. And he sort of wants to point at the time it takes and the waiting problem. I think there's more to learn about how it got like this, but that doesn't undermine evolution at all. In fact, the remarkable similarity between all of the X chromosomes, when they are in fact the stable ones, shows that this wasn't some entity designed them to be the same. It is that we hold a common ancestor, and that's exactly what the paper says.
Well, I said I'd give Mark the last word, so I want to respect that.
Sure. Thank you.
Appreciate it. Good talk.
Yeah, good talk, man. Really enjoyed it.
I don't think I've ever been caught cursing online before.
Name call. So
yeah, but you just said that I cursed out somebody.
My question. Hold on. I'm not finished. I'm
made an accusation that I've cursed somebody out. I want to see that.
My question for you, and this is because Arn Ra just had a conversation with Mary Schweitzer and probably talked about why people are lying about her findings.
What do you mean by like?
What is coming from?
What do you mean by you people?
So how come you haven't written a paper and put that up for peer review in order to counter anything in evolution? Not just the things that you talked about with Mark, but just anything. Or is it just
more people read books and books sell better?
Or is it just the fact that all these predominantly Christian scientists want to get rid of God? Is that the conspiracy?
More people read books and books sell better. That's why I like
but
to
books
write
aren't
books.
as reputable as far as sort
Yeah,
of credibility.
This is why books. This is why books aren't science. Okay,
Oh
thanks.
no, books are
Thanks
based
for
on
that.
science.
At least,
So the
at
books
least you
that I've
admit
written,
that.
So the books
At
that
least
I've
you
written,
admit that. I mean, you do write books with a guy who gets his science from a website that literally in their logo has that it's a troll website. I get that.
So in my books, I cite numerous times. And first, I appreciate your accusations that you can't back up in terms of the cursing.
I can.
Name calling, yeah.
I can.
You know what?
Just
Sometimes,
go.
I guess if you consider Dodgeball Dan and Diaper Dino name calling, then I'll own up to that. Cursing.
I think Erica did a great video about all of your comments in the on
well, we're
different
kind of
YouTube
getting
channels.
aside the point a little. I think we're getting sort of off topic a little.
Yeah, that's not the point. My question is
stop smearing SFT, bro. You're out of here. Stop smearing it.
Why aren't you instead of writing books, writing scientific papers?
Okay, so I'm going to answer his question now. So the books that I write, I enjoy writing books, and the arguments in the books, a lot of them are based on peer-reviewed publications. Here's just
fallacies.
One of them. I'm not sure why the beginning of your sentence is starting in the middle of mine. Okay, so one of the many papers that I cite in my books, in my debates, in my presentations, are from young Earth creationist Dr. Rob Carter, trained geneticist with a PhD in marine biology. This is in the secular literature, mitochondrial diversity within modern human populations, okay? They've actually discovered Eve in our genetics. They have her consensus sequence is what it is.
Ask a question.
It turns out, again, the beginning of your sentence, starting in the middle of mine. So
I wanted to ask a clarifying question before you continue with all of this.
Well, this is the peer-reviewed literature. Would you agree?
Yeah, humans are part of marine biology.
Now you're dodging. You are asking why me, a young Earth creationist.
I'm just.
You are asking why
I'm just pointing out that the guy's not really qualified to write about
Grace,
human populations.
Yeah, I mean, come on, Peter. If you're gonna ask a question, then let him freaking answer the question, bro. Like seriously.
Yeah. Okay. Go ahead.
Peter is asking why I don't publish in the peer-reviewed literature and why I write books. Well, my books are based on a lot of the arguments when it comes to separate ancestry, literal Adam and Eve, are based on the data from the peer-reviewed literature. This is just one of the many papers I could cite right now. This is Rob Carter. He's a young Earth creationist. He's published on mitochondrial diversity. He'd school you day and night on mitochondrial DNA.
Obviously, because I'm not a scientist.
Okay, and so if you actually read through this, which I just had a 3.5-hour debate with Grayson, and we discussed this comprehensively. Okay, what we see in here is supporting evidence for the arguments I make specifically on a literal Adam and Eve. And so they've discovered Eve. They have her sequence, and we are only a few DNA differences away from her. With a fast mutation rate, it's trivial. It's a trivial amount of diversity to explain in 4,000 to 6,000 years. But anyways, the answer to your question, this is a young Earth creationist, Dr. Rob Carter. He works with Dr. John Sanford, right? One of your favorites, I'm sure, has written Genetic Entropy. Dr. John Sanford has over 150 peer-reviewed publications, by the way. And so are you going to disregard Robert Carter? He's published in the peer-reviewed literature on mitochondrial DNA diversity.
Yeah, I'm going to disregard him because
so then you're not really looking for an answer. If I publish in the peer-reviewed journal,
why is your sentence starting in the middle? Why is your sentence starting in the middle of mine?
Touche, Peter.
Yeah, touche. So yes, I'm going to disregard him because if he's written a scientific paper that were related to a fictional character, I really want to see that paper
it's right here
talked about by someone who's actually qualified.
It doesn't. I think that's where we sort of have to.
Well, hold on. I'm going off.
Peter, just a sec. Just a sec.
I don't want to straw man.
Peter, jeez, man. No, seriously. Peter, it doesn't mention Eve at all, and it doesn't conclude in any way that there was an Eve at all. It's just
being
Donny
honest.
is using the data that's in there and making his own conclusion, which the paper does not share.
I get that.
Be
Mark,
honest, it doesn't.
I get that. But what I'm going off of was what Donny just said, that he discovered Eve in our DNA. I'm not talking about what the paper actually says, because 9 out of 10 times when we're talking about a paper and we have Donny in the room, Donny won't tell you what the paper actually says. He will tell you what he would like the paper to say. The paper doesn't say anything about discovering Eve, as in the biblical Eve. That's not in that paper anywhere.
Right.
But Donny just implied that it was. And this is why I can call Donny a liar, because he's lying right here on this show about a paper that doesn't say what he claims it says.
So is it my
now
turn
you can respond, Donny. Yeah.
Okay. So again, another accusation that can't be backed up. Lots of claims, assertions, and basically a demonstration that Peter doesn't understand.
Peter.
Let's just all be honest with ourselves. That entire discussion Mark and I had, Peter didn't understand a word of it. And so all Peter can do is
I wasn't there. I put in the side chat that I was going to be right
I don't know.
back.
Peter might have understood it. He might have.
What I'm saying is that when you pulled this up, you claim that this guy discovered Eve, as in the biblical Eve, make no mistake, in our DNA. People can, this is going out live. It's going to be recorded. It's going to be on this channel.
I've done an entire presentation on this, and so has he.
Exactly. So this paper never mentions biblical Eve anywhere, nor does it make a link from our DNA to this fictional biblical Eve. That is a lie.
Okay, so my turn.
And that is on recording, and so you can tell me that I'm now name calling. No, I'm making an observation. You just lied to the entire audience that this paper makes a claim it doesn't do.
I will gladly allow you.
Just point out where it says, where it points to the biblical Eve. Highlight that section.
I will gladly allow you to read this paper. Take a month. I don't care how
No.
long it takes.
Highlight the section where it mentions the biblical Eve.
You on this paper.
You can do this. You can do this right here. You have it on screen. Highlight the section where the paper addresses the biblical Eve. You can't, because it's not in there. That makes you a liar.
Okay, so Peter's basically saying more things wrong in one sentence than words that are in that sentence. So we can
go back to you saying that
Peter,
it links.
I am trying to respond. Praise, can you please be a moderator and mute this clown?
I mean, seriously, Peter, if you're just gonna be a troll, man, I'm gonna kick you. Seriously, this is your last.
I'm not.
Peter has never been interested.
I want him to be honest.
In intelligent, scholarly, and sophisticated discussion in his life, because he's not a smart, sophisticated, or intelligent human being. He's a moron, capital M. Tell him I said so. Okay.
What are
you going to do, Peter? What are you going to do, you clown? Now shut your mouth. The big boys are talking, okay?
All right. Yeah. Also, I'm going to welcome. We have what's his? Grayson. Yeah, good to see Grayson. I forgot his name. I had to pull it up there, but
hey guys,
Grayson.
what's up?
We're just chilling.
So finally, I can respond to Peter. So this paper, talks about how they looked at mitochondrial DNA variation worldwide. Okay. And by looking at the DNA differences that separate people, they were able to come up with an Eve consensus sequence. You can read the paper for yourself. They talk about the consensus sequence. They talk about how they came up with it. And they talk about specifically the amount of nucleotide differences that separate any two people. The world consensus sequence is unambiguous except for a very few nucleotide positions, and you can go through and read the details yourself. But they talk about how, I'm trying to look at the exact numbers. Okay, so they talk about how we are only about 21 to 25 on average, the mean, DNA differences separated from the Eve consensus sequence. Okay, so notice this. The worldwide human mtDNA consensus is composed of, so the mitochondrial DNA, a very small DNA compartment, it comprised about 16,000 letters. Okay, so what they did, and the most easiest way to explain it, this is where they talk about on average differed from the consensus by about 21. Okay, so I would say between 21 and 25 if we were to go to the most up-to-date data. And for the layperson to understand, basically, if I were to hand, let's say, 10 documents to 10 different people, those 10 people have the original document, and I told them to copy it out a bunch of times. Well, each time that your people independently copy it out, there's going to be mistakes. And so for us to come to a consensus sequence would be easy. We just take all the copies and we find out where they diverge or deviate from each other. We can find the mistakes by comparing them. And by doing that, we can come up again with the original manuscript that we gave them to copy. And so that's what they did here. They looked at worldwide mitochondrial DNA variation. They found all of the deviants, rare and common, and they were able to come up with a mean. And so they were able to come up with that original sequence. Now, we as creationists, we would interpret that original sequence as being Eve's original sequence. And so we have to account for the average 21 to 25 differences from that consensus sequence. The evolutionary community, they would look to that original sequence not as an original created sequence. They would look to it as what's called a coalesced sequence. Okay, and so they would look to previous ancestors, but coalescence has taken place basically at some point in Africa. And so that's the coalesced sequence. And so that's where we would differ. But nonetheless, they have an Eve consensus sequence. We would say it's the biblical Eve. The evolutionists would argue that it's the out of Africa Eve. But the data itself, that's what we would look at, and that's what we would debate. As a matter of fact, Grayson and I did so for about 3.5 hours, and I've had several debates on this specific topic. So yes, Peter's wrong. They have an Eve consensus sequence, okay? And it's not that hard to figure out. Go ahead.
I don't think it's Eve consensus. I think that by saying Eve, you're sort of misrepresenting what is said in this, because nowhere does it say Eve. And sort of, if you're talking about a mitochondrial Eve, well, maybe, but that's known to be deceiving when you sort of say, well, mitochondrial Eve is the biblical Eve, because it's not. It's the most recent common ancestor, which is sort of 120 to 150,000 years ago or so. And these calculations are based upon that frame of reference for years. So we've got, he never actually says that it's in any way related to the biblical Eve. You are just sort of making that assumption because that's what you want the data to represent. That
He's
data
trying to say
just as
about
easily,
inbreeding.
Jason, please. That data could just as easily point to a mitochondrial Eve, a most recent common ancestor of all humans. So when you say it, it shows that there is an Eve, suggesting the biblical Eve. Yeah, that's misrepresentation, Donny. I'm sorry, but I got to agree with Peter on that.
Hey, well, Donny, can I just ask you a question real quick?
Well, real quick. Hey, did I not just say when I explained the paper in detail that the evolutionary community would look to the consensus sequence? Nobody would disagree that it's a consensus sequence. We would argue...
Donny, I just want to ask you a quick question.
Right, but that's a far cry from the paper discovering Eve. Okay, you realize that's a far cry from the original statement.
The paper did discover Eve. The evolutionary community would say that this is a coalesced mitochondrial Eve sequence, but they would place that coalesced Eve in Africa.
Donny,
we would place it somewhere in the Middle East.
Is your average consensus sequence including Neanderthal mitochondrial DNA? Because you would have to in your model, and I don't think that the paper includes Neanderthal mitochondrial DNA, which it's totally blows the Eve timeline like out of the water. But you, in a creationist model, would have to believe that Neanderthals like came from Eve, so you have to include Neanderthal mitochondrial in there as well.
So right here it says the worldwide human mitochondrial DNA consensus is composed of 16,569 nucleotides. So this is living mitochondrial DNA variety, basically. And so that's what's represented on the phylogenetic tree as well. Neanderthals is an extinct.
So how's the Fellowship in the Spirit? Anybody know?
So Neanderthals are an extinct people group. And so,
well, that's another discussion, Dave. Let me finish this. Go ahead. Sorry, guys.
All right.
And the reasoning behind the differences in mitochondrial DNA within Neanderthals would be an entirely separate argument. And so this consensus sequence here is based on worldwide mitochondrial DNA variety from living people. That's how we're able to calculate the mean and basically come back to a coalesced sequence that the evolutionary community would probably place somewhere between 100 to 200,000 years. We would place it somewhere between 4,000 and 6,000 years. That's it. I got nothing more to add.
I would say that probably doesn't even really make much sense, because I think the male is able to carry both the X and Y chromosomes. So if you bring on mitochondrial Eve to start everything, you would have nothing but an XX chromosome and then X chromosome.
Well, the mitochondrial DNA is passed down from the mother's side. So we do, as men, have mitochondrial DNA, but it dies with us. It's not passed on. Only our Y chromosomes passed on.
The end story is that including Neanderthal mitochondrial DNA, as the creationist model should, if it's being consistent, will totally break that entire assumption. Like, it'll totally break their model.
Well, let me ask you a basic question. When we include mitochondrial DNA from Neanderthals, what does the mean become?
Yeah, it's a much greater mean. If you're going to include that, they're much more divergent in their mitochondria.
Be specific. What's the number?
I don't have the number. It's not my study.
Then find the number, come back with it, and then we'll discuss the differences. So as of now,
if you're going to pose a model, right, it should be a model that's consistent with your beliefs. You believe that Neanderthals came from Eve, so they should include the mitochondrial DNA from Neanderthals in your consensus sequence for Eve.
If living people, on average, differ from the consensus sequence by between 21 and 25 DNA differences, when we include the Neanderthal mitochondrial DNA, you're trying to say that it's a major problem for us, but then you won't give us a specific number. Well, that's no help to this discussion. Go Google, find out what the average is when we include Neanderthal mitochondrial DNA, because it's not going to be that much of a difference. It's going to be different, but it's in light of their specific conditions that they existed in light of their highly inbred condition, in light of basically them being hyper mutants, which the secular literature admits paper after paper. It would be easy to account for a few differences in terms of their DNA, but I'd really like to see what the exact number is, and let's see what we're dealing with here. Let's see how much we have to explain.
Well, frankly, I don't have a problem with this paper. I just want to say, Donny, I don't have a problem with this paper. I don't have any problem with it. I mean, it basically just covers, currently living consensus of mitochondrial human. The problem that I have is saying we found Eve.
Donate through YouTube.
That is not an accurate representation.
No, it is. We did find Eve. We found Eve.
No.
The consensus sequence is Eve's genome, her mitochondrial genome.
But you're talking about the biblical Eve, right?
No, I'm not. I'm talking about the biblical Eve. You're talking about the African.
Why doesn't the paper say it's found Eve?
That's what the world consensus sequence is. It's Eve. If you don't understand that, you got to go back to school.
Sequence.
The consensus sequence is what they got based on worldwide mitochondrial DNA.
Mitochondrial Eve is just a nickname given to that consensus sequence. It is not an actual scientific
insult. It's an insult, but you ended up insulting yourself.
It's not an insult. It's in no way an insult. It's just a term
Mark,
people have used to shortcut to something that is highly scientific. It's not an insult at all.
What is the original consensus sequence according to you then?
The most recent common ancestor of all humans.
Okay, and where's that most recent common ancestor located?
Africa.
Okay, and so why do we have a single coalesced consensus sequence of all women today on the planet? Why do we only have one lineage?
It's a mathematical certainty that would be the case.
I'm pretty sure
it's a common ancestor because everybody descended from this group of people.
Okay, how many women existed in Africa at the time?
I think it was 6, but I'm really struggling with my memory at the moment. I think it was 6.
So there was a massive population bottleneck, you're arguing, that took women at that time down to 6?
No.
So you're
no, like just because look, Donny, just because gene lines end, right, doesn't mean that they didn't live at all, right?
Well, but that is one lucky woman.
Well, maybe
only one.
But I mean, as opposed to sort of the probabilities of that versus, you know, sort of
you are unadulterated.
If it's an original sequence.
A God created a woman out of the rib of a guy and then somehow magically, you know,
but
created
you have the
them
same
alive.
amount of faith. You don't realize.
Well, I'm telling you what I understand the scientists to be saying when they're talking about the most recent common ancestor.
From your world
I'm not saying that they're going, hey, it's Eve, which is what Donny's suggesting.
And what a lucky mother to be the only one who survived.
Well, I mean, to be heard, I just want to say something about that rib, too. It doesn't actually say that in the Hebrew. It says curve. If anything, it means DNA curve. I mean, I think if there was some type of genetic experiment going on with God taking it out of Eve. I think he did some type of genetic engineering.
Yeah, I think you're sort of missing the point. You know, if there's magic going on, it's not really the source of where the magic.
No, there's a lot of magic going on. If one lucky woman in all of Africa managed to pass on her DNA to the point where we have a single coalesced consensus sequence, okay?
That's the case in every part of the DNA, though. That's a mathematical certainty to always be the case. You can look at any individual chromosome and you can calculate which individual person was this, like, the same exact equivalent for the Y chromosome or mitochondrial chromosome. You can do that for every chromosome, and it's a different person every time.
You're forgetting. I just want to add this. You're forgetting the fact that what we're talking about here is worldwide mitochondrial DNA.
It'd be worldwide for all of those examples. We could look at the worldwide variation in chromosome 2 or chromosome 6, and we could calculate the exact same individual consensus sequence for every single chromosome, and they're all different individuals.
When we look at there's only one mitochondrial genome. Okay, we're not looking at subsections of the DNA, which if it goes back to a common ancestor, well, then because there's other parts of the DNA, that's by definition going to go back further too. But we are going back as far as we can is the point, because this is the entire mitochondrial genome, all of worldwide mitochondrial DNA diversity. Okay. It converges on one single woman. The evolutionists want to say, well, that's a coalesced.
How do I explain this? Okay, so I'll explain this really simply, Donny, because I think you're totally missing the point. The whole point is it has to be an unbroken female line from female to female to female to female, etc. Right? There cannot be a male in there anywhere. So what we're looking at is the mitochondrial thing of the last ancestor of all women. Like, we're not saying that there weren't other women around at the time or there weren't other people around at the time. It's just that is the last time. Then what are you talking about?
Because you're saying out of all the women, out of all the women that existed on that planet, you are saying that there's a lucky mother who managed to be the only one out of all those women on the planet at that time to pass on her DNA to everybody.
I want to ask a question too. If biblically the woman came from the man, why is it called mitochondrial Eve rather than mitochondrial Adam?
Because the mitochondrial DNA is passed down on the mother's side, and so we're tracing it right back to a woman, and that would be Eve rather than Adam.
Donny, can I ask you a quick question? Could you not use any animal like a rabbit, and you could do the same thing for rabbits' mitochondrial DNA? But you believe that animals were created in groups. You don't believe that there's a single individual like pairing Like you could do this for every single animal, right? And you could do this including for like animals like that you don't believe existed on Noah's Ark too.
Well, let's see a consensus sequence for an animal. Pick an animal, rabbits. Let's see the paper, cite it. Where's the consensus sequence? I don't know if they can do that.
Well, you agree that they have mitochondria, so you by definition, you could do this analysis on any population with mitochondria.
I would say hypothetically, if you had enough mitochondrial DNA from pick your species, let's say rabbits, and let's see if it all goes back to a single ancestor. Let's see if there's one lineage. Do you have that data? Have they done that?
It'd be a mathematical certainty that it would in every single case. That's how population genetics works.
Then prove it.
Well,
Firstly, you didn't know the average in terms of every argument you're making. Prove it. Let's see if they've done that with rabbits or if they've done that with chimpanzees.
Why do you
think it's not a mathematical certainty? You know what? This argument's been made a couple times. It's not a mathematical certainty because coalescence depends on what's called random mating. But random mating is not true historically. Historically, people have existed in tribes and they've interbred and intermarried within those tribes. And so basically, we should have many mitochondrial DNA lineages and not just one. So one mitochondrial DNA lineage is a certainty of biblical creation's true, but not if evolution's true.
And they've also produced men that have then gone on to have children, right? To have female children, right?
Men do have female children. What?
Yes. So they wouldn't have mitochondrial DNA
I've got a daughter.
leading. They would have DNA, the mitochondrial DNA that would not lead back to the last common ancestor, right?
I think Mark's point is that if you start off with
guys,
yes,
but if you start off with a female,
so it has to be an all-female line. So women that only produced boys wouldn't be part of that line, right?
But women can't produce boys, I think would be a point.
No. My point is we shouldn't find one mitochondrial DNA lineage. We should find many mitochondrial DNA lineages because random mating's never been true. There should be multiple mitochondrial lineages. As a matter of fact, we should share some with chimpanzees.
I do not understand why you think that a last common ancestor would result in one woman. It is absolutely insane to me. When you understand that mitochondrial DNA has to be passed down from woman to woman to woman to woman, if we go back as far as possible, we just, you're not understanding why there's more than one woman, but her mitochondrial DNA wasn't carried down because there is no direct chain of woman to woman. It's insane. I don't understand how you can think this.
What you're saying is only the case if there's random mating, but that's not true. We've had people groups existing on the planet in separate tribes, interbreeding and intermarrying and intermingling within the tribes. And so we should find multiple mitochondrial DNA lineages and not just one mitochondrial DNA lineage. But the Bible says we have all come from one woman. And so it makes sense from our position, but it doesn't make sense from your position. And if it does, I challenge you to show me a prediction where they've actually predicted that we would discover one mitochondrial DNA lineage of all women on the planet. Or was it retrofitted? Was it
There's no such thing. It would be
They can't show that ever.
Right,
then why does mitochondrial have haplogroups that fall into different haplogroups like L0 and...
Yeah, that's what I have on the screen. These are haplogroups that are formed through the accumulation of DNA differences, mutations. That's why we have L haplogroups, HVR haplogroups, and those are basically...
You understand that haplogroups form nested hierarchies. So every single time, right, you're always going to be able to trace it back to an individual, like, root of the lineage, like every time. Like that's a mathematical certainty. That's the basics of population genetics.
Yeah, but you can look at each haplogroup and you can see how many DNA differences, how many deviants there are from your Eve consensus sequence. So either way, you are going to go back to that Eve consensus sequence just like they did in this paper right
That's just how it works every time. It doesn't matter if you're looking at mitochondrial DNA or any region of the DNA.
I think you're pressing mitochondrial Eve on people when that's what you're supposed to be supporting.
So notice here how all of your mitochondrial DNA goes back to 3 major haplogroups. So the Christians here on the panel would understand that after the flood, you have 3 reproducing. You have Adam, or you have Noah, his wife. They probably didn't have any more kids. You have Shem, Ham, and Japheth. I hear some background noise from somebody. I think someone might have to mute.
That's me. I'll mute myself.
Yeah, keep yourself muted, please. And so you've got Shem, Ham, and Japheth and their wives. Well, since mitochondrial DNA is passed down from the mother's side, well, Shem, Ham, and Japheth, they're going to pass down their Y chromosome DNA, okay? But they're not going to pass down their mitochondrial DNA. And it just so happens to turn out that mitochondrial DNA worldwide goes back to 3 major haplogroups, L, M, and N. And so to us, that fits like a glove, because Shem, Ham, and Japheth had 3 wives that basically we have all descended from. And it just so turns out that we have 3 major haplogroups that we could hypothetically say are Shem, Ham, and Japheth's wives. I find that to be fascinating.
Yeah, that's not even a thing.
I mean,
well, that's your assertion, Mark.
They all nest within L.
If they had sort of 8 people that you claim, we know that the Akkadian Empire had millions of people living in it, like 300 years after your supposed flood. Exactly how did that happen?
Okay, so you're going to an indirect line of evidence when we're looking here at the genetic data. Genetics is the best way to answer this question of ancestry. And we have mitochondrial DNA diversity worldwide going back to 3 major haplogroups. On this phylogenetic tree, there's only on average between 20 and 25 DNA differences.
I don't know how you're breaking up these haplogroups, because there's like L1C and L1B are the 2 major haplogroups. What's the third one?
Your 3 major haplogroups that all of these branches go back to is L is in the middle, and then you have M and N. And from those 3 major haplogroups, you get other haplogroups.
No, they all nest within L. There's just one.
Yeah, it's just
no. That's based on a rooted phylogenetic tree, and the rooting is based on many unknowable evolutionary assumptions. This is an unrooted phylogenetic tree, and so
who gave birth to Mitochondrial Eve? That's what we're asking. Like, who gave birth to Mitochondrial Eve? Go ahead.
That's not really a question, because if you bring up Mitochondrial Eve, you have to at least bring up between 100 and 200,000 years ago. It doesn't fit in a creationist model.
No, the 100,000 to 200,000 years ago is not based on mutation rates that are observable. It's not based on genetic variation.
It was all mathematics, mate. There was no 200,000 years ago. What they found was, with the mutation rates, and Parsons destroyed this, is they found that when they looked at the mutation rates, it got them back only 6,000 years. So they went, okay, the mutation rates must have been slower or faster or whatever it was in the past. So we're going to go back and we're going to make up all this fantasy about them being faster. Now, what do the evolutionists say? What happens today is what's happened in the past, basically, right? So now they find that the mutation rates lead us back 6,000 to 6,500 years to the first woman, and they say, well, okay, well, that must not be true. Well, because we know God isn't true, so we have to. And then they went out and
none
they made
of this story is true.
None of this is true. Yeah, so I just want to address the haplogroups with M. Basically, the science is saying that M, actually, its ancestor was L3, which came out of haplogroup L.
I think I said it was true.
The sister group to M is actually N, but what we're looking at is one main haplogroup, which is L, and 2 sister or sibling haplogroups, which are M and N. So, you can sort of say, hey, the science is wrong, but you're not quoting science. You're quoting your narrative.
No. That's based on a rooting of the tree. That is based on the assumption that L is your deepest lineage. Every haplogroup nests within L. That is all based on evolutionary assumptions.
What's the assumption?
Where the root is.
So it would just be L.
The root somewhere in Africa.
It would just be L.
We are looking at an unrooted phylogenetic tree, and you are making arguments.
It's rooted
within your mind, a rooted tree. This is not a rooted tree. I didn't pick a root. You didn't pick a root. This is just the raw data. I know you guys don't like raw data because you love your evolutionary based assumptions, because you want to assume that we all came out of Africa.
Is this from Answers in Genesis?
Assumes at least 200,000.
Is this from Answers in Genesis? Is this from Answers in Genesis?
This is a paper written
in
Answers in Genesis. The
Yeah,
data is
that
raw,
explains
though. The data is
that
raw.
explains it.
Okay, well
Yep.
then, you know what? But then let's go to the 1,000 Genomes Project one. Okay, so here we go. Notice how it looks basically the same. Is the 1,000 Genomes Project good enough for you, Mark? Okay, you're dodging, you're ducking, dipping, diving, and dodging all over the place.
Yeah, but
This
a
is the
rooted
raw
tree
data.
doesn't show you much.
No, listen.
Like an unrooted tree does not show you very much. You have
He
to root
just
it.
went against his own
And you
argument.
haven't explained what the assumptions are. You're saying you can't make these assumptions to root it, but you haven't explained what they are.
The assumption is that apparently they're
We
rooted.
debated the assumption for 2 hours. You guys argue that Africa has the most diversity, and since everything nests within Africa, basically your L group there, then Africans must be older than non-Africans, and therefore you pick your root somewhere in your deepest lineage, somewhere on the L.
But you believe in the
you guys
Africa
rooted there,
theory.
and so by definition, a side effect of that root is what?
You honestly
Every
think
other
that's
group
the assumption?
nests within it. Why is there 5 people talking at the same time?
You honestly think that that's the assumption that's being made in order to root that tree? Like the rooting of that tree has nothing to do with that assumption.
The rooting of any tree, evolutionary speaking, is based on the fact that your deepest branches are in Africa. That's a fact. Prove me wrong.
There you go.
Are you saying that I'm wrong, Grayson, on that?
Yeah, I'm saying that that's not how you would root that tree. Like that's
How
not
would
how
you
you
root
would
it?
But you said
determine
that it's
like
rooted somewhere, and now you're saying that it's not.
No,
You're
this
saying
isn't
that
rooted.
It starts in Africa.
no
This
the
is
tree
not
that
root-
he's
I
showing
haven't
on the
chosen
screen is
to root it.
unrooted.
Yeah, this is an unrooted tree. But if you looked at a rooted tree,
But it starts
all
at
of
the
your
L.
haplogroup, it would look like a stair. It would look like a staircase.
Yeah,
Stair-step
so
pattern.
without
You've got all-
a root to your tree, your comparisons don't really mean much because you can't measure any of the genetic distances because you don't have a root, like you don't have a 0 point to start at.
Right, but here's the thing: you guys are the ones
Neither do you.
that pick a root based on many unprovable assumptions, and so it is a side effect. It is a side effect of the rooting when you pick somewhere on your L branch.
The genetic
It is a side
sequence
effect that
determines what the
everything
root is.
nests within it. Okay, but realistically, okay, let's say I'll use one example out of 20 that I could give. Okay, let's say we had a selective sweep across Eurasia that resulted in all of your older lineages basically being wiped out, with only your older lineages in Africa remaining or surviving. And so now, because of that, we pick a root on your deepest branches. Okay, and
Hey,
now,
standing true.
well,
Just-
wait,
just
wait,
one
stop,
second.
stop.
Just-
And as a
sorry,
side
Standing
effect,
True. Do you want me to get you that thing from Parsons? I've got it on my thing where Parsons destroys these people. You know, they say that do you want me to find that video? I can find it and post it in the side chat for you if you want.
well, we did, yeah. What Jason's talking about is we emailed Parsons because I've got his paper here. I actually pulled it up earlier, but we got back onto this. I have it down here. So Parsons discovered the faster mutation rate, where basically your mitochondrial Eve only goes back 6,000 years. So a lot of people have criticized him on that. And so where's the paper? It's right over here. And so we actually emailed him, and he's not a creationist. He's an evolutionist. And he basically, here's the paper, or at least a commentary of it. And so it talks about this article noted the new findings of faster mutation rates pointed mitochondrial Eve lived just 6,000 years ago. And it's resulted basically in some amazing DNA research in the FBI. So a lot of evolutionists on YouTube and angry bloggers, they've criticized his methods. TJ Parsons, I believe it is. So we emailed him 2 years back, sent him the criticisms from like Erica and Dan and CRISPR and all these guys. He sent us a real funny response. He said, if they have a big problem with my methods and data, then guess what? Publish in the peer review something better in the peer reviewed literature. And guess what? That's never been done, because these are just angry evolutionary bloggers and YouTubers. They don't like the data.
Kind of
they don't
going
like
off
the data.
topic a little. I mean, yeah, you're just sort of complaining at the moment. Can we get back to the subject?
So here's the subject. We have DNA variety worldwide in terms of the mitochondrial DNA. It goes back to 3 major haplogroups. We can't root it. Creationists can't root it. evolutionists can't root it. Now, we could say as creationists, you know what? Maybe there's 3 main roots. And so every single haplogroup or people group came from these 3. Because if L, M, and N really do represent contemporaries, Noah's 3 daughters-in-law, then basically every single human today came from those 3 nodes. And so we could make predictions. Jensen has, that's his book Trace. That's a whole nother story. So we could say that. Or we could just say, you know what, this correlates well, but the data itself is what's most important. Low variation, fast mutation rate, only a few haplogroups. They're all pretty close together. That's what we'd expect in the separate ancestry model. Go ahead.
But we wouldn't, because those 3 women who apparently were on the ark, which is a ludicrous story.
Well, that's your
wouldn't
assertion.
expect to see.
Just
we
down
wouldn't expect to see.
And in the chat.
Really? We wouldn't expect to see what we do because it's concerning populations. You're saying that each group, so the main one, which is the L group, that we can tell was the main ancestral line going to Africa, and the M and N, which are sibling groups that originated from one from L3 and one from, I can find that. So you want to challenge all of that.
Well, why did M and N come from L? Why did M and N come from L? Why
because we can trace. I mean, I know that M is from Asia, right? So it's from Eurasia, correct?
Well,
so you're not saying, hey, we only find these haplogroups associated with the geographic regions they're in. You're trying to say that's wrong, are you?
Well, we could, like, for example, you know, down here's your HVR haplogroup, your most common haplogroup in Europe. And so there's genetic markers in here. Okay, in people groups, you know, there's genetic markers that can say, hey, you know, I belong to this haplogroup.
Yeah.
Historically. Okay. And so you can basically bundle all of that up into a phylogenetic tree, and you can see where your 3 major haplogroups are, where your sub haplogroups are. And so I think that's basically what you're saying. But nobody would dispute that you do have 3 major haplogroups with a lot of sub haplogroups that basically come from those haplogroups. You would say everything nests within L. And so M and N came from L, and HVR ultimately came from L. Is that right, Mark?
You're on mute. You're on mute, Mark.
So this is for the macro haplogroup M. So when we're talking about M and not sort of L0, L2, L3, we're talking about the macro haplogroups as opposed to, say, L3, which was a haplogroup. But everyone, like, it's fine.
Right.
So this is a paper saying that they colonized India from Southeastern Asia. Like, we can look at the populations that live in these areas, and we can tell the spread of these populations from the mitochondrial DNA. And you're basically saying, hey, for some reason, that ends at the macro haplogroup. You know, M came from exactly the same place as N. That is not what scientific peer review research says. It's just not, Donny. I'm sorry.
No, but my question, you're missing my question. Why does M, N, and basically all of your sub haplogroups, micro haplogroups, as you can say, why do they all ultimately come from your macro haplogroup L?
Well, it doesn't. It comes from L3. It's a haplogroup. This is what M came from. And N, I would have to look it up. It comes from a different haplogroup within the L series. And we can trace that back as well. So we can tell.
I'm trying to ask you. N,
yeah.
But the reason why you're saying M and N consequently come from L3 is because you've rooted the tree on the L series, is my point.
Why would we say it comes from L3 and not L1 then, for instance?
Well, we wouldn't root it on anywhere on the L.
But if that's what the mitochondrial DNA suggests, why wouldn't you?
No, but what about the mitochondrial DNA suggests that?
Well, I'm not a biologist and I don't do genetic research, but that's basically what...
They're not arguing, they're debating, mate. There's a difference.
Well, me and Mark don't argue. So
look, Yeah, see, because there's going to be a limit to my knowledge. At some point, I've got to say, hey, these papers say this, and I'm not sure of the reason why. I mean, I can look into it. I'm happy to. But when sort of they say, hey, we can trace the mitochondrial DNA back to the main group L and the subgroups M, which came from L3. And look, I'll find out where the N group came from. Give me a sec.
Well, the reason why they're saying that these various groups came from, let's just call it the L series. When you get different mutations, enough of them, and you have these basically genetic markers that can create a new haplogroup, okay? Even within your macro haplogroups, let's say. But anyways, their starting position is that L series because it has the deepest branches. It has the most genetic diversity. And so they have everybody coming from Africa. And so your L series there, L3, specifically, that's your deepest branches. And since the branches reflect DNA differences, that means that lineage has the most genetic diversity. And nobody would disagree with the fact that Africans have the most genetic diversity. But I just gave you 1 out of 10 reasons why that could be the case. We understand that selective sweeps happen. We understand that, populations move in, war and conquest takes place. And so if there was a selective sweep across Eurasia where all of your older Eurasian lineages were basically wiped out, and then your older lineages in Africa are all that remain, well, that's not testimony to age. That's a testimony to other factors besides age. And so when you root the tree on your L node, let's say, and now everything nests within the L, that's all based on a false starting point.
Okay, Donny, you're making it sound like the choice of where to root this tree is like some arbitrary decision that the scientists are doing, and it's not like a quantitative program where they're plugging in the sequences, and it's a quantitative process that is purely an accounting for the sequence. I mean, they're not telling it which node to root on. There are lots
Grayson,
of phylogenetic
I want you to take as much
programs
time as you need, Grayson. I appreciate what you're saying. Take as much time as you need. Okay, let's just have the tree on the screen. Where would you root it? And then tell us why. And you can give us 5 reasons, 6 reasons, make it quantitative, as you've said.
Okay, yeah, you need to actually get the actual DNA sequences for all of the endpoints on all of those nodes and plug it in to a phylogenetic root program, which exists. You can go to GitHub, you can find them, and they use different quantitative models to try to place the root.
Genetic trees in the literature, only 18 are most popular.
Yeah.
Which one are you talking about?
So if we trace them all back through the mitochondria, they end up with your most recent matrilineal ancestor, which is a direct female line to the mitochondrial Eve, if you will, if that's what you're using to describe it. Sure. That's what you get. And we know that's in Africa because that's where the mitochondrial DNA is the most similar to. I mean, we still have people in the L haplogroup today. But, I mean, I don't understand.
Yeah, but they're looking at genetic diversity in Africa.
Right. Well, there's genetic diversity everywhere. That's what happens over 100.
But Africa has the most diversity.
I don't think so.
No, Africa has the most. Actually, diversity within Africa is greater than all of non-Africans, basically. And Grayson, I think you could attest to that.
Yeah, that's true.
Right. So your Africans have the most diverse tribes within Africa have more diversity between each other than they would to non-Africans. So nobody's disputing that there's a lot of diversity.
But what's that got to do with the matrilineal ancestor being traced back to the L haplogroup? What has that got to do with it?
Because it is genetic markers and DNA diversity, as well as your pieces of DNA. So, for example, Africans have more pieces of DNA and therefore more recombination. All of these things are why they put Eve in Africa.
So that's not why the other haplogroups nest within L. Okay, that's a totally separate reason. The reason the haplogroups nest within L and just L is because of quantitative methods based on the DNA sequences, right? And they can do this analysis on any individual population and find their common ancestral data.
Yeah, but
that
selective
way.
sweeps are going to give you the same side effect. And it has
Look.
nothing to do with age. It has nothing to do with coming out of Africa. It could easily mean we came out of the Middle East. And so there's a lot of assumptions behind where the evolutionists pick a route and also say mitochondrial Eve originated.
No, Mark already explained it. Like on Earth today, where where that has the most common same group as the L group, where all of these nest within are in Africa, not the Middle East.
It's based on genetic data, though.
Yeah,
You're
exactly.
assuming
It's
that the
based on
African
genetic
lineage is
data.
Yeah, it's
available.
based on
hard
genetic data.
evidence. It's quantitative.
But the genetic data doesn't tell us that your mitochondrial Eve originated in Africa, or that we all came out of Africa rather than the Middle East, or Africans are older. That is the assumptions you guys are making.
Hold on,
Okay, we understand that mutations are variable. We understand that recombination rates are variable among people groups worldwide. We understand that selective sweeps have occurred historically, which can get rid of older lineages in different people groups and keep other keep other lineages. Now, all we would have to say from the out of Babel model is that basically more people out of the Babel dispersal made their way into Africa. We have waves and waves of people going into Africa, which makes sense geographically coming out of the Middle East. They're pretty close to each other. And so we have many of Noah's descendants moving into Africa. And as a result, they're bringing lots of diversity into Africa to start with. And so you have Africa with more diversity. And as you move away from Africa, you get less and less diversity. And so you have this nesting pattern that is not necessarily reflective out of some hypothetical out of Africa dispersal event. It's a reflection of other factors that you guys aren't considering. Go ahead.
I'm just going to sort of, I got to go. So I do apologize. I've sort of been here for ages, but I thank you so much for having this talk. I just want to show something before we go, because I've been looking around for a picture to show Donny what I mean when I'm talking about stuff. So I do apologize. It took me a little bit. And sort of, Donny, I mean, I know that's your sort of narrative, right? I know that's sort of what you're saying, but there's nothing to suggest that besides your own claim it is so. Well, all of the genetic evidence suggests the L group is an ancestor. No, all of genetic evidence suggests that the M and N groups are nested within the L group, the L macro haplogroup. So, I mean, if you want to challenge that, then like Peter was saying, produce a peer-reviewed paper. But I want to focus on this because this answers the question of why you're saying. Like,
I'm familiar with that image. I'm familiar with that image.
If there was only one woman, if you knew clearly
because that image, because that image is a reflection of what I've been saying this whole time. What is on that image is based on an assumption that historically we have random mating, and therefore you can get, as you can see here, you get one woman. Oh yeah, it is.
No, it's not.
Yes, because if you don't have random mating, then you don't only have that one woman in the middle there, the black line, that's basically leaving her lineage.
Daughters
into all extant people today. Notice how you got the black
daughters,
in the middle, right? And you have only her having daughters and basically passing on her mitochondrial DNA for us to have one in lineage. That is based on random mating. Historically, we've had people in tribes, and so we should actually not have that. We should have dozens of that, not just one. We should have dozens.
Still don't
of that.
Understand? Yeah,
well,
no, that's not how it works. Because when you get back to the L haplogroup and the base haplogroups for all of those individuals, they're becoming smaller and smaller populations of people. That's why.
It doesn't matter, because in Africa you have a lot of.
Matter.
Yes, it does. Because it doesn't matter how. Wait, stop. Listen, we don't need the peanut gallery here. Okay, me and Mark are having a big boy conversation.
Talking biology, man. That's who you are, man.
Okay, so anyways, me and
It's
Mark
not an
are
argument.
finish this off because Mark has to get out of here. Okay.
Yeah, I do have to go. I do apologize. So sort of tracing it to one genetic group.
Mark. You don't have to apologize.
Yeah, that's okay. I just, I don't want to dash and sort of leave it at this, but yeah. So
no, it's not okay. You wasted our time. You better apologize because you're not a biologist to talk about.
This has been fun. This has been fun. Not a waste of time.
Well, I mean, neither are you, presumably.
And let me point this out. this is the topic of tonight. Praise put on a show about evolution, and you know what? We got a good group here talking about evolution. Mark, I'll give you the last word again because I appreciate your time and you're also a good sport. So I just want to say this. Wait, Mark, let me just say this one thing, and then you have the last word, which will be a disagreement with me, and that's okay. I respect it. So I would argue that you're never going to get what this image says, and I guess you'll disagree with what I say, but this is, again, assuming random mating worldwide historically. Even in Africa, you're going to have different tribes, different groups of people, not just all intermingling in one area where this could be the case. We have random mating in, you know, this population of humans that are not really isolated in sub-tribes. No, historically, we understand that you'd have sub-tribes and, you know, there's intermarrying, intermingling, interbreeding within those tribes. And so my position is that you would have multiple of these lineages if evolution is true and not just one. Now you have the final word and point out why you disagree with me and I'm wrong, and I appreciate this. Go ahead.
Yeah, so it's because we can sort of tell by the mitochondrial DNA of currently, it goes back to our last common maternal ancestor. So the last woman that had a direct female line to all females of today. And that doesn't mean they're alone by themselves in the world. It just means that there is no other direct line that is connected to every single person. And that's perfectly understandable in evolution, and the whole idea that it leads back to an Eve, the sort of the way we know it precludes this is because we have other input from genetics on the male side, for instance, that doesn't share the same markers that go back to this one person. It goes back to a group. So you know, this isn't the only evidence for evolution, but it does assume random mating. Random mating doesn't mean anything to genetics when you look at it. Genetics doesn't sort of go, oh well, those people acted randomly, so we're going to get a different result. It says exactly the same thing. But thank you so much for your time. I really appreciate it, and I'd love if we can have a conversation sometime else. But I do have to go, so. Thank you so much for having me on. Love you, everybody. Take care of yourselves. Take care of each other. And
God bless you, man.
Night.
Thank you for joining.
Good discussion.
Appreciate you later, Mark. Appreciate it, Mark. Thank you very much. Okay, so that was fun. That was good.
I have a challenge for Grayson. I'm sorry. I said I'm sorry.
Grayson. Yeah, but Grayson just